Alright, so in this video I'm gonna be explaining another important article about domain adaptation. And when we have domain shift, then there are three different types of domain shift. One of them is concept shift, which is the topic of this paper. The other one is covariate shift. The other one is label shift. So we focus on this, although it is hard to decouple the rest of them. So this paper in 2023, pre-trained language models have been tremendous success in text classification problems in the context of natural language processing. In many real-world text classification tasks, the class definitions being learned do not remain constant, but rather change with time. This is known as concept shift. For example, when coronavirus comes, then all of your symptoms about flu could be now a different meaning. It could be something else. It could be corona. So the concept shift is like this example. Most techniques for handling concept shift rely on retraining the old classifiers with the newly labeled data. However, given the amount of training data required to fine-tune large DL models for the new concepts, the associated labeling cost can be prohibitively expensive and time-consuming. So we propose a reformulation. We convert the vanilla classification into an entailment-style problem that requires significantly less data to retrain the text classifier to adapt to new concepts. But what is concept shift? Concept shift occurs in a data stream when the contextual relationship between textual inputs and labels changes with time, resulting in a change in the conditional probability of y given x. In the case of concept shift, the data distributions remain constant while the posterior change. For instance, consider a medical setting where the aim is to make a prognosis for a patient based on their age, severity of their flu, general health, and their socioeconomic status. So in that reference, in reference 2, the classes are originally defined as remission and complications. But at test time, other aspects are counted as a form of complication and are so labeled. What constitutes the positive and negative class, and by extension the posterior distribution, has changed. A typical example of concept shift would be that the incidence rate of a particular disease in a certain groups may change over time due to the development of treatments and preventive measures. Concept shift in text classification can occur due to various reasons, such as sudden change in external circumstance, occurrence of pandemics, gradual change in semantics, like words taking on newer meaning. Consider the case of classifying a healthcare research article as relevant or irrelevant to a user. Under the usual circumstances, the user may not be interested in healthcare research, but during pandemics, his or her preferences could change. So what is concept shift? You see, this is the covariate shift and this is the concept shift. When the probability of distributions are the same, but the probability of label in the source and the target given your data is different. So they have this contribution that we show that reformulating vanilla classification as an entailment can help augment pre-trained language model performance in tackling concept shift. We provide appellation to highlight pre-trained language models' few-shot capabilities for tackling concept shift in text classification. So this is a few examples from datasets we use for our study. For the top retail queries, we provide the reasons for shift based on labeling guideline change. For bottom, we provide the topics under which shift happens. So, for example, when we have this title, Australia march into dominant position against New Zealand, timing pack paper stock to watch Tuesday. So there is a pre-shift to post-shift. So it's irrelevant to relevant, or relevant to relevant, and the other case is relevant to irrelevant. So for example, we have query and product, vacation things, bug bite section 2. So it could be irrelevant and then becomes exact. It could be irrelevant, then it's substitute. So consider the query product pair. For example, iPhone and Samsung Galaxy. To be aerial, irrelevant, and now substitute in the concept shift training data. Then we create 3 VE examples, negative examples. For example, iPhone plus Samsung Galaxy changed to exact and 0, and 1 positive example. So once the model is fine-tuned on the concept shift training data during inference, say we encounter the query or product pair, we compute the argmax of probabilities of the following augmented inputs. So we train that, and an inference we have final label, which is the argmax of P of exact, sub, comp, and error. So L is the set of labels. The training dataset can be segregated based on the labels of the training, and let the concept shift be these labels, where X sub I is the set of training data available for case label after the concept shift. For a given data point X, for a given data point whose pre-shift label is L sub J and post-shift label is L sub J prime, we create a total of K augmented samples with binary labels as follows. Now, 1 is the indicator function, which takes the value 1 only when the argument is J prime. Otherwise, it is 0. So prompt of LK is remained LK match when LK is L sub J. So these are binary labels. And after creating these augmented examples, we fine-tune on a binary classification task. During inference, the predicted label for a data point is obtained by taking an argmax over probabilities outputs by the binary classifier over the augmented samples for any I in tests. And then they compare it against the baselines. They see the F1 score for example, retail queries shift data, or even synthetic data, AG News shift data. So they also have retail, this label shift. So upon deploying our final entailment-style approach for adapting our internal models to the sudden concept shift, we were able to re-achieve production-level performance using 25% of pre-shift irrelevant query product pairs.